The blizzard of February 26 is finally over. Let's recap. This video is sponsored by ZoneWatch, the severe weather intelligence mobile app and web dashboard. ZoneWatch has an amazing centralized view of local conditions, weather alerts, and automated forecasts from all models, not just one. I know, I usually discourage apps for high-stakes weather conditions where human analysis is king. But for those other times when weather is more settled, I highly recommend this Weather Information Supercenter. For higher stakes weather situations, I use ZoneWatch Radar for live observation videos and reels. You've seen them. It's NextRad based. It features the best precipitation type depiction I know of. In addition to past and present radar, I can view future models like the GFS, Canadian, even the Euro, through the future simulated radar and many other parameters. ZoneWatch is launching ZW Cast in the next few weeks, which features physics-aware forecasting 60% more accurate than NOAA-HER model. I'll put a link in the description if you want to sign up for ZoneWatch with a free trial. And now on to our weather video. Hey everyone, it is about 4:30 p.m. on Monday, February 23rd, and the third and final phase of this snowstorm has completed. You can see the precipitation's just making its way offshore, and so we had the low do something like this. Came off the northern Outer Banks, tucked really close to the coast off Delmarva, and now it's probably out to about here. And we can see that on SPC mesoscale. See this? It's about a 972, so it is down to 972 millibars, about 250 miles east of Cape Cod. But it is long gone, and now we dig out. The winds are sort of light out of the northwest for most of Jersey away from the ocean, but they're still kind of gusting to maybe 25, 30 miles an hour along the south coast here, including the Delaware Bay. So, nothing too crazy there. And then as far as coastal flooding goes, per the Stevens flood advisory system, it looks like we maxed out at the low end of moderate stage coastal flooding. So again, no full moon, no new moon, no crazy rainfall draining in with no place to drain. You really just had the wind-driven storm surge component of this, and the direct easterly wind when the low was still sort of immature. That really wasn't a strong east flow early Sunday to mid Sunday afternoon. It was just a light east flow. When the winds did crank up, it was more of a northeast direction, which doesn't blow the ocean into the inlets. Really, it just sends a chunk of water against the Jersey coast, and for those reasons, we maxed out in moderate. So another thing was that the power outages weren't really that bad or widespread as they could have been. There were some. I did see power outages reported, but I thought there would be a lot more. So these are good things, right? These are good things because a storm that powerful can really go either way. Now there was some thunder snow with this, because it was so warm Sunday during the day in many areas, and because it cooled down so rapidly, you had the precipitation bringing that cold air downwards, and then that warmer surface air has no place to go but upwards in response to that downward precipitation moved air. So you have the convective currents, rising air and sinking air, and that's the recipe to create some conditional symmetrical instability that creates the thunderstorms. So there was some thunder snow, but not as much as you think. I saw a lot of people who were mistaken power transformers blowing as flashes in the sky, and they make their own little tiny boom, but nothing like an actual lightning bolt. So I think there was a lot of that going on. So I guess we can move on to snowfall. So our entire F zone almost verified. No real problems there. Lots of 18 to 24, a lot of 24 plus in Monmouth County, some parts of northern. Um, Zone E, mostly verified in New Jersey. Uh, the only county that did not report a 12-inch measurement is Warren County. Now, Sussex, Warren, and Hunterdon, and a little bit of western um, Morris. So let's draw a little area around that. These areas in New Jersey, there were lots of measurements below 12 inches, but there were a few measurements above 12 inches. So, it's really, the windier a snowstorm is, the harder it is to measure. But these areas did receive less snowfall than the rest of the state, and we'll cover why in a little bit. So what you had was what's called a very large band of snow, a convective mesoscale band, and you had an area of subsidence to its northwest. So I stole this image from uh, Bobby Martrich at EPAWA. He put out a tweet this morning highlighting, the reason why those areas in Jersey got robbed. And I understand this is New England. It's just that this is when Bobby was able to capture the same exact thing that happened in New England as happened in New Jersey. So when you look at this, pretend, let's do this, make this easy. Pretend like this is that northwest area of Jersey that got robbed, right? And then this is the rest of the state that got slammed, right? Just pretend that looks like Jersey. So these yellow areas, very heavy precipitation. On model guidance, there was strong frontogenesis modeled, which is upward rising air, upward motion. That's what brings the warmth and the moisture up, condenses, and falls back down as snow. So wherever you have the areas of greatest lifting, that's where you have your greatest snowfall rates. And a band just like this just parked over northeast Jersey down through like West Jersey, southwest Jersey, between about 1 a.m. and maybe 5 or 6 a.m. this morning. And that's what got a lot of those areas up into that 18 plus zone in like southwest Jersey. You're talking like Marlton, Cherry Hill, Mount Laurel. They saw a ton of snow in that window. The snowfall rates were 2 inches plus per hour during that time frame. But then all this lifting here, rising air has to come down somewhere else, and that's what it does when it rises in a linear segment. You'll have a parallel linear segment where the air is sinking, and it's just in response. Where it rises, it has to sink. It's just like rip currents on the beach, right? You have a lot of waves flowing in. Whenever you have a hurricane out in the ocean, it's pushing swell into the coast. All that water is coming to the coast. The water has to return back to the ocean, right? So it all kind of funnels into a concentrated area and returns back into the ocean. And those are rip currents that go out, ones that swimmers get caught in and stuff like that. Same principles in the atmosphere when you have rising and sinking air. So rising air, it lowers pressure, it brings moisture from the surface up, condenses and falls. Sinking air increases pressure, it dries out the environment, and hence you have a big band of what's called subsidence is the term for the sinking air. Let's go back to the radar for a second, and we can paint it a little bit better. What happened? What am I looking for? This is what I'm looking for. So we'll clear that out. We'll get a little closer on Jersey. All right, so you had the snow storm shield that ran like this, right? That was like the northwest extent of the heavy big snow, and you had that monster band set up right around here, which meant that this area. Well, you know what? Let's draw something else before we draw that. we also had a an inverted trough that was running like this. Now this brought its own set of light to moderate snowfall along that area. Just a few inches, not a big deal. But an inverted trough is also heavy lifting. So between the heavy lifting of the inverted trough and the convective banding that was being emitted from the coastal low, you had a big area of subsidence in here. And I know I pointed this out on a few videos this week as a potential something that could go wrong. Um, and that's exactly what happened for these counties here: Sussex, Warren, and Hunterdon, a little bit of Western Morris, and a few spots down here might have been clipped, like extreme Western Salem County. I'm seeing like some people are saying they only got 6 or 8 inches down there when there's like 18 to 20 around them. So yeah, I'm not sure. I'm not saying that you're being untruthful or anything, but honestly, measurements throughout the whole state are just weird with drifting and everything. Again, the windier a snowstorm is, the harder it is to measure snow. So that's basically how this all wrapped up. The three phases performed on time for the most part. The coastal flooding was minimal. The winds did rock for a little bit along the coast, but they weren't that bad. Here's a satellite view this morning of the low pressure system off of the. It's not quite where it is right now, so this is a few hours old. But just incredible to see all these features. You have everything here that is textbook classic mid-latitude cyclone, right? When it wraps around to the south like this, it's called a sting jet, where snow can actually make its way in here. You have you see this right here, it's a rope cloud. So this area here is a thunderstorm front. So you have incredibly strong thunderstorms, possibly tornadic cells. I think a few people pointed out in that area. And then of course you have the whole precipitation shield with the maximum snowfall area right there. You have the cold front, right? That's pushing in like this, and you have the warm front that's wrapping around up this way. Classic Norwegian cyclone model with the conveyor belt mechanisms, right? You have the warm front, the cold front, cool front, and the greater the difference in temperatures that are clashing, the stronger these mid-latitude cyclones get. But yeah, it's a classic. It's a historic snowfall for New Jersey, especially East Central New Jersey and parts of Southeast New Jersey. So that concludes the storm tracking, the storm observations, and analysis for this. I guess have a great rest of your Monday, and best of luck digging out. Be safe.